All right, so guys, today we are talking about inductive reasoning. This is chapter 2, section 2. Very interesting section, so you'll find that out very soon. All right, so our warm-up, I want you guys to go ahead and access the book online. Use the following steps. So 1, go to that website. 2, click on the section New to Big Ideas. 3, enter that access code. Make sure you are entering it exactly how it looks. If you're getting an error, it's because there's no extra spaces anywhere. There should be capital letters. There's hyphens, and maybe you transposed a letter. Make sure you're entering that code correctly. Your username and password must be kept in a safe place. If you lose them, I manually have to reset them, and it's not very fun for me to do. Plus, I don't want to be doing this at crazy hours, and I probably won't be doing it at crazy hours when you guys are doing your homework. So tough luck. Keep it in a safe place. Don't lose it. Don't forget it. All right, so conjecture. So 2 of the vocab words that we are learning in this lesson are conjecture and inductive reasoning. A conjecture is an unproven statement that is based on an observation. So if you see something and you make an observation about it, for example, when my friend goes to the movies, they eat popcorn. That could be not a proven statement. Maybe they've gone to the movies before and they haven't eaten popcorn. It's not 100% foolproof. Inductive reasoning, a process that includes looking for patterns and making conjectures. So inductive reasoning is looking for patterns of unproven statements, okay? And then looking to recognize a pattern and make a statement about them. All right, example 1. So describe how to sketch the 4th figure in the pattern. Then sketch the 4th figure. So for this one, let me see if I'm able to, there we go. Okay, so figure 1, the circle is split up into 2 sections and one of them is filled. In figure 2, it's split up into 4. 2 sections. This one's 4 sections. And figure 3 is 6 sections. So now we're trying to figure out figure 4. Well, it looks like they're taking the figure number and they're multiplying it by 2, or they're increasing by 2 each time. So it should have 8 sections, because we found out our pattern. Let's go ahead and draw a circle. That was really bad, but let me see if they... Oh, I don't know what I just did there. Well, and let's divide it into 8 sections. And let's shade one of them. This is what figure 4 should look like, okay? 8 sections and one of them is shaded. Sorry, I'm trying to erase the other one so we don't get confused, okay? And how we sketched it is we noticed the pattern was the figure number multiplied by 2. And that's how many sections we had. All right. All right, so example 2, describe the pattern in the numbers 5.01, 5.03, 5.05, 5.07, etc. Write the next 3 numbers in the pattern. So our pattern is pretty obvious for this one. They're adding 0.02 each time. Okay, So the next two numbers in the pattern should be 5.07 plus 0.02, which will give us 5.09. And then same thing, 5.09 plus 0.02 gives us 5.11 or 5.11. So our next ones would be 5.09, 5.11, and 5.13. Okay? Pretty simple. It's all about finding that pattern. Okay, numbers such as 3, 4, and 5 are called consecutive integers. Make and test a conjecture about the sum of any three consecutive numbers. So let's start with small numbers. Okay, and then we're going to test with those just because they're easier to manage. So let's take 1, 2, and 3. It says, make and test a conjecture about the sum of any three consecutive numbers. So if we add these together, we get 6. Let's try 2, 3, and 4. Add them together. We're going to get 5 plus 4, which is 9. Let's add 3 plus 4 plus 5. This will give us 3 plus 4 is 7 plus 5 is 12. Do we notice a pattern yet? Okay, let's keep going. 4 plus 5 plus 6. Okay, this will give us 4 plus 5 plus 6. 9 plus 6, which is 15. Well, what I've noticed is that we're increasing by 3 each time when we're going up. But how does that relate to the numbers that we're using? Well, let's take a look at these middle numbers. Okay? The sum of three consecutive numbers is always the middle number multiplied by 3. Okay? So if we take 2 times 3, we get 6. That one works. 3 times 3, we get 9. That one works. 4 times 3, we get 12. And 5 times 3, we get 15. So the conjecture that we can make is the sum of any three consecutive integers is 3 times the second number. You could have wrote or the middle number. Okay? The sum of any three consecutive integers is 3 times the second number. All right? Now, you can also try it for larger numbers. So let's take 100 plus 101 plus 102. We would get 100 plus 101 is 201, plus 102 is 303. If you took 101, you multiplied it by 3, you would get 303. That one makes sense too. Okay, so just showing you guys that it is a valid pattern, and it works for lower numbers, it works for larger numbers. It's safe to say it works. Okay, counterexample. So to show that a conjecture is false, oops, let me take that out. Just provide one example for which the conjecture is false. So that example is called a counterexample. So a counterexample is just proving that any conjecture that you write could be false. It's an if-then statement. If an if-then statement is false, if an example can be found for which the hypothesis is true, but the conclusion is false. That example is called a counterexample. And here's an example of it. If you live in Florida, then you live in Miami. Well, some of us live in Davie. That's a counterexample because we also live in Florida. Okay? Now, not all of the counterexamples are that easy to find, okay? But you will be asked in the homework to find examples of counterexamples. All right. Find a counterexample. A student makes the following conjecture about the sum of two numbers. find a counterexample to disprove the student's conjecture. His conjecture was the sum of two numbers is always more than the greater number. The sum of two numbers is always more than the greater number. Well, the first thing I think about is I think of negative numbers. So let's take 6 plus negative 2. The greater number is now 6, but when you add them together, we get 4. So the sum of the two numbers is not, 4 is not greater than 6. So this is our counterexample. Okay? All right, deductive reasoning. So use facts, definitions, accepted properties, and the laws of logic to form a logical argument. So deductive reasoning is not based on conjectures. These are based on facts and definitions, accepted properties, and the laws of logic, okay? So these are more facts. Inductive reasoning was more, oh, let's find a pattern. Let's figure out what we can conclude. But remember, deductive reasoning is things that we know are true. Things that we know, oops, that was really bad, know are true. And go ahead and beneath that, I would like you to write that there are 2 laws of logic. And you guys will need to memorize those laws. Okay, 2 laws of logic. Okay? And we're about to talk about them. So, the law of detachment. The law of detachment states that if the hypothesis of a true conditional statement is true, then the conclusion is also true. So, if we know that a conditional statement is true, that's one of those if-then statements. If the hypothesis standalone is true, then we know that the conclusion must also be true. So in this statement, the conditional is if it's Friday, then I eat pizza. So that's a true conditional statement. Every single Friday, I eat pizza. Let's just say that. And so P is our hypothesis, and our hypothesis says that today is Friday. The law of detachment says that I will eat pizza today. It's saying that this standalone, today is Friday, leads us to believe that you will eat pizza today. Okay? So as long as our hypothesis and conclusion form a true conditional statement, then the hypothesis standalone infers that the conclusion is correct as well. All right? The law of syllogism. So the law of syllogism is a little bit different, okay? This is when you have 2 separate conditional statements, okay? So for example, if we look down below, if the hypothesis P, then the conclusion Q. If that's true, and then if the hypothesis Q, then the conclusion R. So it's taking the conclusion from this one and it's putting it as the hypothesis for the next one. Okay? Then the conclusion R, we are able to say that the original hypothesis P, then the conclusion R. Okay? So a way that I always remember this is, do you remember this segment addition postulate? That was saying that LM equals LN plus NM, so long as N is between, that's really hard to see. Between L and M, right? This is basically saying the exact same thing. So if we can have this conclusion Q, right, as a hypothesis as well, leading to a conclusion R, then the hypothesis P and the conclusion R would form a conditional statement that is true. Okay? And we will look at this more often. I like to think, so syllogism, I think of like it flows, and then detachment, you are literally breaking it off. So you're taking the hypothesis by itself, and you're taking the conclusion by itself and stating that they are each true. So you're detaching it from itself, from the true conditional statement, and syllogism is it kind of flows. All right. So there's an example. Given two true conditionals, write a new conditional statement. So if it's Friday, then I go to the movies. If I go to the movies, then I eat popcorn. So what you guys have to recognize here, take out a highlighter, okay? This is very important. I go to the movies. That is our conclusion from the first statement. That was our cue, right? Then our cue is being used as hypothesis. I go to the movies again. Okay, then I eat popcorn. You can just eliminate that, and your conclusion is, if it's Friday, then I eat popcorn. Example 5. If 90 degrees is less than the measure of the angle R, the measure of angle R is greater than 90 degrees, but less than 180 degrees, then angle R is obtuse. Okay, it lies somewhere between 90 and 180. The measure of angle R is 155 degrees. Using the law of detachment, what statement can you make? So let's go ahead and locate. This is our hypothesis, and this is our conclusion. So if the measure of angle R lies between 90 and 180, then angle R is obtuse. This statement right here is telling us that it lies inside our parameters. Okay? Therefore, we can just break this off and just say that angle R is obtuse. Okay? That is the statement that we can make because we can detach the conclusion from the hypothesis and we can make it as a standalone statement. Okay? Remember, detach, law of detachment. You guys really need to know those laws, okay? So get familiar with them. Example 6. If Janelle gets a job, then she can afford a car. If Janelle can afford a car, then she will drive to school. Use the law of syllogism. What statement can you make, okay? So again, take out your highlighter. Highlight in blue the common hypothesis and conclusion. So if Janelle gets a job, then she can afford a car. If Janelle can afford a car, then she can drive to school. Well, the consistent one is she can afford a car. If Janelle can afford a car, then she will drive to school. So now our new statement is, if, I should not write in a highlighter. What? I don't know what's happening. There we go. Sorry, guys. So if Janelle gets a job, then she will drive to school. Okay? Syllogism, you're taking out the middleman. The middleman is she can afford a car. Okay? So if she gets a job, then she can drive to school because she can afford a car. All right? You are taking out the middleman. You're taking out that Q. Okay? You can also, if it helps you, always write it P to Q. And then you can say that Q to R. So now you know you can go P to R. This is our R. This is our P. And these two are our Q's. All right, moving on. No, I'm really bad at spelling it. Syllogism. Example 7, state the law of logic that is illustrated. If you get an A on your math test, then you can go to the movies. If you go to the movies, then you can watch your favorite actor. If you get an A on your math test, then you can watch your favorite actor. Well, this one, it's pretty clear which one it is. So it says, if you get an A on your math test, then you can go to the movies. If you can go to the movies, then you can watch your favorite actor. you going to the movies is being used as both a conclusion and then a hypothesis. So we can go ahead and take it out, and then they just wrote, if you get an A on your math test, then you can watch your favorite actor. Therefore, this is the law of syllogism. And yes, Okay, so example 8, state the law of logic that is illustrated. If x is greater than 12, then x plus 9 is greater than 20. So if you like, and I highly recommend this, actually, you guys should all highlight in red your hypothesis, highlight in blue your conclusion. So if x is greater than 12, then x plus 9 is greater than 20. The value of x is 14. This is saying that our hypothesis is true. So what can we conclude? That our conclusion is true. This is the law of detachment. Because we are basically drawing a line down here and taking these as separate entities. Okay? Law of detachment. Okay? The value of x is 14. That's clearly bigger than 12. So you're saying that the hypothesis is true. And then you are also saying that x plus 9 must be greater than 20. Oh, where'd that t go? Okay. All right, can you apply the law of syllogism to the following? One of them you can apply it, one of them you cannot, okay? So we've got if x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. So this one's a little tricky, and I'm going to explain why. If x is greater than 5, then x squared is greater than 25. I noticed that x squared greater than 25 is used twice, right? But it's not in the order that we're used to. So what they did here was they reversed them, okay? So they said that x greater than 25 was used as the hypothesis first and the conclusion second. You can just reverse these. So if x is greater than 5, then x squared greater than 25, and then put the other one on the bottom. If x squared greater than 25, then x squared greater than 20. So now we can go ahead and highlight them again. And we're golden. So they match up in the way that we're used to. The law of syllogism can be applied, and we can rewrite this as if x is greater than 5, then x squared is greater than 20. And that is our final result. All right, if a polygon is regular, then all angles in the interior of the polygon are congruent. If a polygon is regular, then all of its sides are congruent. So our common hypothesis is if a polygon is regular. It's only being used as the hypothesis. So we cannot, I keep doing that. We cannot apply the law of syllogism. Okay? Because it has to be used as a hypothesis and a conclusion. Okay? All right, example 10. Decide whether inductive or deductive reasoning is used to reach the conclusions. So whenever you are asked to find the difference between inductive and deductive, go ahead and put above inductive pattern. That's when you're looking for a pattern or conjuncture. And then deductive is facts. Okay? Each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, it will return to the ground. Each time, okay? Whenever you see that, I would recommend thinking exactly of a pattern. Okay, Monica's noticing a pattern, right? She's noticing a pattern that when she kicks the ball up, it's automatically going to come down. That is not always true. It's not fact, okay? So this is inductive for A, all right? All reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile, okay? So these are facts. Therefore, it's deductive reasoning. Okay? And our last slide, per usual, is the homework. You guys have got some problems. There's not that many. Good luck. I will see you guys tomorrow. And as always, stay safe.